Okay, so good afternoon, everyone, and welcome to this new training webinar organized by Data4PT. It's 2 o'clock, so we will start the session now. For your information, this webinar is recorded, so if you have any objection, please share it with the chat now. And if not, we just continue. The record will be made available after the webinar to be disseminated for communication. So this is our third training of a series of webinars held in the last 2 months on behalf of Data4PT project. We have started with a training on transmodel. It was on 12th of April. And then we had a training on Siri a few days ago on the 8th of June. And for your information and reminder, all the related material is available on Data4PT website. Today, the topic of this new training webinar is NeTEx, and more specifically the EPIP, the European Passenger Information Profile. The objective of training today is to share feedbacks on the description and some detailed use case of a profile. Our 2 experts today are Christophe Duquesne and Ulf Bierzing. So Christophe is in charge of the NeTEx working group at the European SEN standardization body. And Ulf is involved since many years in European standardization work and European projects. Anastasia Funta is also here with us today as manager of Data4PT project, and will share a short overview of the project in introduction of this webinar. So let's go through the detailed agenda for today's webinar. So we will start with few general words on Data4PT project to remind the main goal and framework of the initiatives. So again, it will be Anastasia who will share this information. Then Christophe will introduce the context around NeTEx and the CEN public transport standards. Ulf will take the relay to introduce the concept of profiles. And then we will have the 2 main core parts of the today training webinar around the EPIP, the European Passenger Information Profile, with the first part to share the scope, framework, and the stop profile, and a second part to deal with networks timetable, common rules, and profile compliance, plus data quality checking. And then the last part of the webinar will be around the technical artifacts with XSD and any relevant artifacts. So this will be shared by Ulf. We will then go through some technical examples, and to conclude, we'll share the available documentation and related tools which are already available. And we will have, at the end of the webinar, a time slot to share any question and answers. So we invite you during the webinar to share any questions using the chat. So feel free to ask any question during the presentation, and at the end of the webinar, we will address it one by one to give you some answers. So I wish you a very pleasant webinar today, and I will now leave the floor to Anastasia to introduce DATA4PT project.
So good afternoon from my side and welcome to our webinar today. I will say very few words about the project. Some of you have already participated in the other events, so you know more or less what we are doing and what is the framework. But for those who attend for the first time, just few words about the duration of the project. So it's a 4 years duration project. The funded comes from a CEF program. And the coordinator is UITP. IT4PT is responsible for the technical management. And there are also other 9 partners, which are member states. And we have also identified some other member states to play the role of the observer. Both groups also participate in workshops and stakeholders forum, but their main activity is really to tell us what are the needs and what are the requirements, and they will also help to pilot implementation of our outputs. The project is a program support action, and its main scope is really to support member states in the development and deployment of European public transport data standards, and in particular the trans model and NeTEx and Siri. We have adopted different approaches to provide support to member states. One way is the training, but we have also in our pipeline to produce tools that will help validate data sets for NAPS, for the publication in NAPS. We have set an experts team, and our speakers today make part of that team, in order to provide customized technical support for those that they needed. And we have also organized events and workshops to exchange experiences and best practices between stakeholders. And our goal is also to propose a sustainable business model for this kind of support after the end of the project. As Emmanuel already we have uploaded the training material of the previous trainings for those who didn't have the time to attend, or they would like to go back and listen again. There is the recording, but there are also the PowerPoint presentations available. And in the same platform here, under our Data4PT Project EU website and the tab knowledge database, we will also upload the material from this training. And just to also say that we will have more things in autumn. So we are planning to organize more training events, most likely to support the transition between the standards that they are currently used and NeTEx and Siri. We will also organize the second stakeholders forum in October. And we also foreseen to the release of validation tool for the pilot use in 2022. So this is from my side. I give the word back to Emmanuel, and I wish you also a very nice and pleasant and useful training. Thank you very much.
Thank you, Anastasia. Again, all the relevant and related information, Data4PT, are available on the website. So we just share the link to the training material in the chat, and you also have access to the project website, which also include last information and link to the technical support. So let's now start with presentation of NeTEx and SEN public transport standards context. So please, Christophe, the floor is yours.
Thank you, Emmanuel. So let's start. I'm Christophe Duquesne, as explained by Emmanuel, I'm leading the NeTEx group at CN level, but I'm kind of involved in pretty much every work related to transmodal, so theory, also Opera, and everything, and transmodal itself. So this first part of the training is really to put NeTEx in the context of the standardization and relation with other contexts and have an overview of its scope. So for those of you who have already attended to the theory presentation, that's very similar to the introduction we had for theory, but this one will of course be focused on NeTEx. The first thing I would like to show, so that kind of just kind of complementary to what you see with theory if you were there, is other data categories that are covered by NeTEx. So starting from the bottom, on the bottom you have the topography, which is mainly the infrastructure, the road, the rails. This is not the scope of NeTEx. It's important because there's sometimes some confusion here. NeTEx is not describing the road network and is not describing the rail network. It describes how it is used for public transport, but not the network itself. However, there is a bit of infrastructure described in NeTEx. For example, you have the point of interest, you have the parking, carpooling areas, and taxi stand, which are really physical stuff on the ground, can be seen as being part of the topography. So this is covered by NeTEx, and then NeTEx is covering everything about the network description and the stop. So the stop is the logical stop. We will be back on it. We will call them scale stop points, but also the physical part of the stop, so where you have the stairs, the lift, and transfer keys, and so on. It covers the network description, so having the line, the route. So the route really defines where on the infrastructure the network is running. But NeTEx is also describing parking and car sharing station and bike sharing station. We will be back also on the fact that now NeTEx is covering new modes. So car sharing and bike sharing are obviously in this kind of new modes. So that's not only legacy public transport covered by NeTEx, but also what we usually call new modes. So this is the network description, and then there's a service description layer where you have all the timetables, the vehicles, the calendars on for each journey to be able to know if they were in from Monday to Friday and from June to September or whatever. But you also can find here the description of fares. So you will have the fare offer description. It's not ticketing. It's not operating the fares, but that's describing what is offered. What rights you will gain when you buy a ticket. So that's for parking, that's for taxi, carpooling, car sharing, bike sharing, and of course for everything in public transport. And the top level is the real-time information. So that's mostly not covered by NeTEx. So that this is the scope of theory, which is complementary. But I have raised the carpooling offers here, because carpooling offers can be proposed quite long in advance. So for carpooling, so a driver can say, I go from Paris to Nantes, and I'm available to get people, but that will be next week. So this is scheduled, this is planned, so that's why it can be covered by NeTEx. That's not the real-time carpooling, which is covered here by NeTEx. This was one view you can have of category, but of course there are a lot of other possible more transverse view. I'm just giving some examples here which are covered by NeTEx, but you have, for example, equipment, and equipment can be in station, in point of interest, on the road, in vehicles themselves. So that's kind of transverse, and the figures on the right, I'm not going to detail it, but just to show that we have quite an extensive, very comprehensive list of possible equipment. Same thing for accessibility, which is very transverse. You can describe the accessibility of vehicles, of the network, of a stop place, or of a point of interest. So the accessibility information is available pretty much everywhere. You have roles and responsibility to be able to tell that who is owning specific equipment or place or vehicle, but who is responsible for operating them, who is responsible for maintaining, and so on. data frames, which is a way to group data together. So that's a set of transverse concepts that are also covered by NeTEx. And of course, every single category I described before can be detailed with, for example, for PT schedule information, you have the lines, the network topology, the timetables, operational information. So it's quite large. NeTEx is covering a lot of needs for passenger information, but also for operation, for fares, and so on. So that's quite a very large scope. It's also important to relate NeTEx to the business of public transport. The public transport is large and also quite complex, and then that also makes NeTEx quite large and complex. And there are a lot of specific point of view from each business level. So the first one is the analysis of needs and the definition of what is expected for the next route, the transport plan, usually defined by the authority. Unfortunately, it's rarely defined digitally these days, but we do have some input where NeTEx could be used here. The big part where NeTEx is used is the scheduling and production plan definition. So once the operator knows what is expected by the authorities, is defining the network itself, and is defining the routing, the scheduling, the timetables, the run times, and so on. So that's what you see on the right with the example of screens you can have on scheduling systems. This information can be then provided from the scheduling system to the operations, typically to AVMS. This is really also one place where NeTEx can be used to transfer the information from the scheduling to the operational system. So where you will have the run of the system, but this level will mainly provide information for theory, will provide the real-time information. And then there's another layer, which is the passenger information layer. Obviously, this is really also one of the big scopes for NeTEx, where you can have journey planning, when you can have the journey planning on web, but on apps you can have map provisioning. You can have schematic or geographical maps, or any service or information about fares and so on. Indicators and statistics is what analyzes what happened during the operation. This will be more the scope of OPERA. And the fare and ticketing, the fare offer and the definition linked to the ticketing system is partly the scope of NeTEx. NeTEx is only describing the fare offer and not doing the ticketing, but can be really the link between the description of the network, to be able to describe the fare offer that can be sent to the ticketing system that will operate the ticketing. So that was a quick overview of the scope. NeTEx is not standalone, it's connected to other standards. So the main one is Transmodel. Transmodel is our data model, which is giving conceptual description of what the public transport is. What I mean here is that Transmodel is going to provide the list of all the objects we can manage in public transport, and is going to provide the relations and the main attributes of all these objects. But that's conceptual. From this, NeTEx is making an XML extended format, so really based on Transmodel, but instead of having UML, it will provide an XSD, XML. It could be JSON also, exchange protocol. And also coming from Transmodel, you will have Siri for the real time and OPERA for the operational road that has what happened on the network. So these three, NeTEx, Siri, and OPERA exchange protocol, are fully aligned and derived from Transmodel, and that's important to have this in mind, to understand that everything is consistent between all these four standards. You may wonder how GTFS and GTFS-RT fit here. You probably know GTFS, which is the standard initially coming from Google. In fact, it's from Primate and then managed by Google, and it's now managed by Mobility Data, and we're strongly connected and working together with mobility data. And so GTFS has a use case where the main use case is to provision data for journey planners. So, and he's doing this very well, and it's really for traditional passenger information. So it's only covering a very small subset of NeTEx. It's good standard, and usually it's nice when you provision data to have NeTEx and GTFS, usually that you will extract from the NeTEx data flow. But so you can see really GTFS as a small subset of NeTEx. Same thing for GTFS RT for Siri. All this is in a global ecosystem, so having Transmodal at the center, so you can see once again NeTEx, Siri, and Opera, but there's also on the top OGP, which is Open Journey Planner, so an API for Journey Planner, which is also related and based on Transmodal, but also the ZAP sale for rail or EBSF, you will have some inputs about it. On the right, you have the former national standards like Noptis, Neptune for France, or Transoceanic for UK that were they were all already based on Transmodal. So Transmodal is here for a long time, have been used quite extensively from the 90s up to now, and is evolving to cover all the new needs of public transport. This is the global scope of Transmodal. So with part 1, 2, 3 for network timing information and vehicle scheduling, the part 4 for operation and monitoring, 5 for fare management, 6 for passenger information, 7 for driver management, 8 for statistic information, and the new part 10 for new modes. And if you look at what is the scope of NeTEx, so it's smaller, it's covering, so obviously the timing and network information, passenger information, fare management, and alternative mode, which is a new part of NeTEx. NeTEx is built of 6 parts currently. So part 1 is so you have here the number for NeTEx. I've stopped at 3, but it now goes up to 6. So part 1 is common concept and network description. You have also a lot of use cases for NeTEx described in part 1, so that makes quite a big part. Then it's complemented by part 2 for the timing information. The part 3 is providing the fare information description. The part 4 is EPIP, is the passenger information profile for at European level. So that's what we will focus on, and it's a very good introduction to NeTEx. The part 5 currently under TC reviews. That's the last time before European vote at CN level. So that's the description of all the new modes in NeTEx, and we are just now starting a new part, which is the accessibility profile. So part 5 is already a profile for passenger information, and we are now trying to build a profile for accessibility at European level. So this is what NeTEx is doing, taking a model which is like this one, a UML model from Transmodal. Here you can see the line and accessibility information related and network. And from that UML model, we have an XSD, which is XML schema definition, which helps providing XML, which is the document we are going to extend. So NeTEx is mainly doing that, providing that XSD to go from the schema to the XML. At the end of the day, it will look like this. This is an extract of what you can see when you open a NeTEx file. Basically, it's very close to what you see when you open an HTML document, or if you look at what is in a docx document from Word document, that's also like XML. So it's not difficult to read. The good point is it's human readable. So if you see name here, so you understand that that's the name of the stop place there. So you can read it. It's possible. It can be quite big, but that's not difficult to manage. The mods covered by NeTEx are here. It's quite comprehensive as regards the mods. The mods are mainly the type of vehicle, and for each type of vehicle, which is a mod, so you have sub mods and what we call mods of operations. So scheduled operations, flexible operations, so on-demand operation, and for all what we call new mode or alternative modes of operation, you have vehicle pooling, so carpooling, typically vehicle sharing, so car sharing, bike sharing, motorbike sharing, whatever, and also rental, which is covered by NeTEx. So the coverage of modes by NeTEx is quite comprehensive. Some examples of what you can do with NeTEx are feeding journey planner, or obviously passenger information system feeds, so provide some more static information, describe a line. It's more and more used for open data feeds, specifically now that there's a regulation making it mandatory for national access point. But as said before, you can use NeTEx to feed the VMS, so to take the information from the scheduling system and to provide this information to the VMS who will run the operation. Also extends information between operators so they can cooperate a network or some line or part of a network. NeTEx can be used for early schedule information extent, but also for later updates, and you even can provide information with NeTEx for a specific day, what we call dated journey. That's kind of where is the overlap with Siri. Siri manage only dated journey. NeTEx usually manage things with calendar and with a longer term timing window, but there's this small overlap here where you can use dated journeys to be extent, same as Siri, but not the real-time one. And also ticketing system feeds, of course. But in fact, there's quite a lot of possible use cases of NeTEx. To end that presentation, I want to give you a few words about profiles. So profiles are built by consensus, meaning there are experts coming from every country involved in building or interested in building the standard. And we do find a consensus, so that means that we have requests coming from every single country to make sure that their local needs will be fulfilled by the standards. But that means that there are a lot of also sometimes a bit specific or features that are for a certain country but not for the other. So you may not be interested in everything in NeTEx. Also, as said before, you can use NeTEx for passenger information, but you can use it also for feeding a fare information system, or you can use it to go from the scheduling system to the VMS, so more on the operational side. So it's quite large because it's covering a lot of use cases. And also, if you look at what you will see it later on, but there are a lot of non-mandatory features, optional ones, and you may decide that this non-mandatory feature should become mandatory or should not be used anymore for any reason. As an example, in UK there is the NAPTAN, the National Stop Reference Database, and obviously they make it mandatory to use the IDs of NAPTANs for every single stop place. But that don't mean anything for other countries. So there are a set of specific local rules that you may want to apply. All this means that you will probably create profiles when using NeTEx. You're only going to use everything, and you're going to provide additional rules on how to use NeTEx for a specific kind of extent. This will obviously facilitate implementation and interoperability. Sometimes you have several choices of doing the same thing in NeTEx, so it's important that everybody involved in an exchange make the same chance, the same choices. Sorry. So profile is just focusing on what is needed for a use case and filling the gaps when there are some, and adapting to the local context. And this is typically what EPIP is doing. So EPIP is European Passenger Information Profile. It's defined to be a simple profile, so it's not covering every single need, but covering most of the traditional need you will find at European level for passenger information. So that's the profile we're going to dive in deeper today. Okay, so nothing else. We have here as the last slide, but I'm not going. We will be back on that. As said, you will get that slide, of course, that presentation. A set of reference to resources you can find online for NeTEx tools, profiles, and of course the standards itself. Okay, so I'm done with this first presentation. I guess that will be Ulf now presenting the next step.
Okay, can you see my slide?
Mm-hmm.
Thank
Yes.
you.
Thank you.
Yes, I will continue where Christophe ended here. Talking about profiles. So just as Christophe said, profiles, they're focused on only what is needed in a specific context. I mean, NeTEx is a huge model and with many redundant constructions, but to work in actual cases where we connect different partners, it's very important to be able to focus on what is really needed. And also, as Christophe said, sometimes filling the small gaps that are voluntarily left by the standard. So, for instance, we will talk a lot about the EPIP profile today, but just to give you some other views, I will also talk a little about some other profiles. So in this picture, you see the EBSF profile. And also remember that we use the concept of profiles, not only with NeTEx, but also with Siri. And of course, NeTEx, that is planned data, and Siri is the real-time data. So I'll give you two examples. I will show a bit about the profile used in the European Bus System of the Future 2 project, and then a bit about the Nordic profile. So first, we look on the European Bus System of the Future project. It was a field test for Transport for London regime. And it was done in cooperation with the partners from many different countries around Europe. And in something we do not cover in the other profiles mentioned today, it also covers vehicle schedule data, the operational data, describing how the vehicles are how their working day is organized into blocks where they conduct a number of vehicle journeys and dead runs. So here we have, in addition to the timetables and calendars, also vehicle schedules. And the use case was that we had a large number of providers that needed information so they could run their AVM systems, their automatic vehicle monitoring systems on the bus that they were responsible, the real bus in London they were responsible for. And what we had to work from, it was a bespoke database that consisted of information well organized with networks, timetables, and vehicle schedules, but it was not in any standard format. So one of the partners converted this bespoke data to NeTEx. So the idea was that one party do the conversion work and not everyone, and then all the providers can use the same standardized data based on NeTEx. And to do this, we spent a lot of time together, partners from different countries, Sweden, Germany, Switzerland, France, England, and discussed what parts of NeTEx we should use and under what conditions. So we defined the documents, and we decided that we would use one XML file for each line, and we covered about a sixth of the complete operation in London and operated this for some years. So there was one XML file per line, which contained the service journeys and related info. And then there was one XML file per operator and depot with operational data, including blocks and dead runs. And then there was a shared file for the stop places, keys, links, etc. And this gave some pretty usable sizes of the files. We were around 10 meg here in the files, which was workable. So let's look on the Nordic profile, which was originally the Norwegian profile, and it's basically built from Norwegian needs, but it's also been adapted for use in the Nordic countries. So what we have is a very extensive and easy to understand documentation that is easily available on the net, and it contains relevant examples and descriptions. So this is very useful, and you can see in the slide the address where you can go down and how it is described. And in this case, the national access point, NTUR, receives information from the different regions, fylken, and then you can, from this national access point, anyone can download data, and the data is organized in a multiple file concept to reduce the size, and you have one XML file per line also here, and it refers to external data for stops and keys, which is available nationally, but there's also reference to combined regional data of interest. And in this case, it's things like calendars and mappings between scheduled stop points and stop places, etc. So this is a possibility here to link information using local identifiers to the national identifiers for stops, so everyone knows what key you mean, regardless of from what region the data comes. And the data, we won't dive into it now, but it looks something like this if you open it in XML Spy. But these are not the only profiles, and there are many different profiles, and some are very easy to produce. Some are not so easy to produce for everyone, but they're very compact. And this partly is because it's possible to use some different redundant constructions. We can see here a few different NeTEx profiles. We've gone through the EBSF2 profile. It's based on the call concept, so they're very close to the Siri data. NeTEx allows you to use calls to describe your journeys. It's an expanded format. It's denormalized, making it easy to produce without anyone misunderstanding what the information means. Also, we actually had both denormalized and normalized information in parallel in this profile to cover for all different countries' needs. And it's, of course, consistent with the Siri profile for European bus system of the future too. Then we have the German profile, which is very well documented. It uses a link runtime concept, separately describing the wait times at stops. It's very compact. It has a very high degree of normalization, and it uses a concept of time bands, which is a requirement in Germany, but it's kind of hard to use in some other countries where you haven't built the data from the time band concept from the beginning. Then we have the Norwegian Nordic profile, which is passing time based. It's an expanded format, but at the same time, it's partly dependent on normalized information. And of course, also here you have a very good consistency between the identifiers used in this NeTEx profile and the Siri deliveries in Norway. And lastly, we have the European passenger information profile, which we will talk more about, and it's passing time based. And it's expanded, but at the same time, partly dependent on normalized information. It's a heavily reduced profile compared with the complete NeTEx profile. Yes, so what we're talking about is here the profile for the EPIP, the European Passenger Information Profile, which is very interesting in relation to the demands in Europe for these national access point, and it forms a good basis to be able to share information between different European countries. So finally, I would like to say here that we in Data4PT have made a contribution to simplify the work with these extremely large NeTEx set of XSD files. There are actually 379 XSD files in 31 different folders if you want to work with the complete NeTEx. What we have provided is 4 XSD files that covers all aspects which are relevant for the EPIP. And these are available for Data4PT. And we'll talk more about that later. Now, some ideas here. Use stable unique identifiers. We'll come back to this. And these should be shared between Serial and NeTEx. So when you work with profiles, assure that you have a consistency between your Serial and NeTEx profiles. And I think EPIP or the Norwegian profile are good places for inspiration. And a suggestion, consider using the EPIP identifier convention. Another aspect is that you can construct tight profiles, but maybe you need to have different profiles for different usages. Maybe you need a different profile for the provision of data to an aggregator and another profile for easy reading in the open data end after the aggregator. Okay, thank you.
Thank you, Ulf and Christophe, for this introduction around NeTEx and profile. So we have now 2 dedicated slots to go deeper in the EPIP, the European Passenger Profile. And first 40 minutes, we'll now focus on the scope, framework, and stop profile of the EPIP.
Yeah. Thank you, Emmanuel. So what you see on the screen is the European Passenger Information Profile. So just to say it once more, it's a simple profile for passenger information. It has been defined first to fulfill the expectation from the regulation from the European Commission, which is focusing on passenger information, and it has also been defined to be as simple as possible, but also covering the main needs across Europe. So it's a CN document, so it really has the structure of a CN document. So you have to be aware that you can't do a CN document the way you want. There are some rules to follow. So all the beginning of this document, from 1 to nearly 4, or kind of mandatory chapters, which are the introduction, the context, and presentation information. The first really semantic information starts here at chapter 5, where you will have the framework. So all the information like versions, code-based frames, or reusable points or links and so on. So all the concept that will be used all over by a lot of other objects. Then you have the chapter 6, which is about stops, describing the stop profile. So I will do the first part with the part 5, and Ulf will do the stop profile, because we will have a break at the end of stop profile, and then I'll be back to the network and timetable profile, so network description and timing information description. There's a very small chapter also that will be presented about flexible services. And then there's a set of rules that's very important in the profile, so we'll present them, but about how to describe and structure IDs of objects. So what kind of frame do we have, and some rules also about file naming and file splitting. So this is not fully in the scope of the standard itself. That's some additional or complement information, but which are usually important when you define a profile and when you want to implement a standard. I'm not going to describe everything on the top, the context, the European forward, explaining what NeTEx is, what is the context, what our theory, and so on. So you have a scope. One thing you may be, so there's, as a chapter 3, so the external reference, there are terms and definitions. This is not the data dictionary. These are really some terms that are used, like conceptual data model, the data domain, entity, and so on. This is not the dictionary. There is a dictionary at the end of the document. We will maybe have some time to have a quick look through it. But the dictionary really take all the business objects and give you the official transmodal definition. So the definition of concepts, as said before, is coming from transmodal and reused by NeTEx. Then there are some stuff about presentation conventions. It's important, for example, when you see things in uppercase like line or scheduled stop point, when it's uppercase, that's a transmodal concept and a transmodal word, so that's important. But when we're talking about XML elements, it's bold and italic. So you have here, it's not long, but you have here the explanation and the way we use lower camel case and some that's writing conventions, but that helps to understand everything. A small thing here in all the tables, so you will see that we have all the tables describing all the attributes of all the concepts. When there's a gray area, that's something which is not in NeTEx, not in the standard, but which is a specific complement for the profile, the EPIP profile itself. And when there's something in blue, it means that it's not selected by the profile. In fact, you will not see anything in blue in the final document. They are hidden. We didn't remove them. So if you ask Word to show the hidden parts, you will see all that blue. That's why we talk about them. So we will not see them today. But when we decide to not use something in a profile, we don't remove it from the profile. We just hide it, so it's easy when we want to update the profile to bring them back if needed. So now we are in the core of the profile itself, starting with the framework. And the first thing, which is a very important object in NeTEx, is that data managed object and version management. So we have that figures here, which is also coming from transmodal. These are very generic concepts, but when you extend the information with NeTEx, you will need to update. So the object will have a life cycle and will update the information about line by passing times about the stops, so that may change their names, that may move, or you may add one or remove other one. So each object can be provided several times with updates and have different versions, and each version will have a validity condition. So NeTEx is designed so that you can, for each object, provide its version and associated validity conditions, so when you can use it. And even in a single file, you can have 2 times the same object with 2 validity conditions. For example, if you have a stop and you know that it's going to move or be renamed in 1 month from now, you can provide the current version, we would say version 12, which is valid for the next month, and also provide the version 13, which will start in 1 month from now, maybe for 1 year, with another validity condition. So these are generic information you will have in NeTEx, and it's also object as what we call a code space. So if you are familiar with XML, you probably know namespaces. Here we have code space. That's the same thing, but for IDs. So that's a way to say who was the originator and to what to relate that object. The idea here is that if you have, for example, 2 operators in the same area, they will most probably both have lines, and if you take their line ID, the first operator will start at line 1, line 2, line 3, and so on. And the ID for the second one will also start as with line 2, line 1, line 2, and so on. So if you want to be able at the identification level to make the difference between these two objects, you need what we call the code space. We will be back on it, but that's also very important to have this kind of management of identifiers. So this is the data managed object, which is here. Any single object, standalone object in NeTEx is a data managed object. So all the attributes you will see there are available for pretty much every single NeTEx object. The first thing is a responsibility set. I already gave a few words at the beginning about this. So for each object, you can give information about responsibilities and roles. So you can tell who is the owner of the object. You can tell who is operating this object. You can tell who is maintaining it. And so that's a set of roles. It can be one organization having multiple roles, but it can be a set of different organizations. So that's something which is available at mostly in any object. One other thing is that you can in NeTEx have extensions. Extensions can be a generic XML extension. We didn't select that in NeTEx, so there's the global extension where you can add any kind of XML stuff. That is not selected in the profile, but we do have in the profile something what we call key values. So you have an attribute where you provide its name, it's a new name plus a value, and that's a simple way to extend NeTEx when necessary. And also for every single data managed object, you can have some branding information. So what brand it is related to, and what brand should be provided as information for passenger information. So there's a lot of branding from operators, from authorities, and that's very useful to have this possible branding at any level. So what you see here are the attributes table. So you see our data managed object, which is here, and our data managed object is inheriting from entity inversion, which is that object which is itself inheriting from entity. So, you have quite a huge use of the inheritance mechanism from Tanzanel and back to NeTEx. And if you look at the details of the attributes, maybe I can make it bigger here. You see the data managed object with from the entity inversion, it will get the ID here, and then a set of attributes saying when it was created, when it was changed, what was the last modification, the version, which is very important. And you can also have a status. The validity condition. So we decided to have a simple validity condition, which is what we call valid between. So was a set of from date to date for the validity, which is simple. You could have also in NeTEx triggers saying if there's a flood or if there's such event or a specific event, you can decide to trigger something. This is not selected in that profile. We just kept things simple with the valid between. So from date to a date. You have the responsibility set, so the role assignment for the data management object, the KLIs we're talking about, and the branding ref. Another thing which is useful is we have alternative text to provide alternative to all the textual information we have. I'll be back on it later. So validity conditions, you can see here the details, and you can find the from date to date. Responsibility set. I'm not going to describe all the details of responsibility here, but you can see from here, so you have the data role types where you can say this specific organization either collects, either aggregates, either creates the information, and you have the stakeholder role type where you can say that this stakeholder, this organization is planning, operating, or is the legal ownership of the object. We do have more possibilities in NeTEx, but these are the only ones that were selected for this EPIP profile. So profiling is also about selecting the codes you want to use when NeTEx provides a lot of codes, possible codes. So the key list, as I said before, you have a key, which is a name, kind of a name of attribute and the value. So if you don't have what you need in NeTEx, you can add these ones. We have a strong rule here saying, obviously, you don't have to create key or a key value extension for something which is already somewhere else in NeTEx. That may sound obvious, but I faced several times situations where people were, let's say, a bit lazy and they didn't know what was exactly in NeTEx, and instead of starting what is inside, they added some specific key values in it. So that's definitely not something to be done, and that's explicit in the profile. You really have to use K-list only for specific additions. Usually, that K-lists are very often used when you have an existing system with some specific IDs you want to relate to the, or for example, for ticketing specific IDs which are very local, and you still want to carry them, and so you will say, okay, that's a ticketing. The K would say it's the ticketing ID for this company, and then having the value that helps that company to relate the object to their legacy system. As said before, code space are very important. I'm just going to focus here on this example. Here, for example, we have defined two code space. One is NAPT for NAPTAN, so that's the national sub database in UK. We give him a name named NAPT, so it's proper NAPTAN here. The code space describes exactly what it is, that's the description. We also have ERA, European Rail Agency, here with the link to the ERA. So that will be to give information, to identify information coming from ERA. And when we are going to do some identification, each identifier will have a prefix being the code space. So for NAPTAN, they will all information provided by NAPTAN will have that NAPT prefix. And then when you will make a reference to it, you will keep that. And doing it this way, you can make sure that even that number is complex. If somebody else, another organization, reuse it for anything else, it will still be unique when extended by this NAPT extension. But that's something we are using quite extensively in NeTEx for identification. So this is a table for describing code spaces. Frames. The frame is an important concept also. So in NeTEx, we are talking about data exchange. So data exchange is basically you're going to create a file or have an API that will send you all full data set at once. But this data set is expected to have only objects that are consistent with each other. So the lines will refer stops. So you will need to have that stop somewhere, and you will need to have the stop with a consistent version, with the version of the line you're using. So you don't have to have a line referring stop which will send, which have been sent or whatever. So that's a way to keep things all consistent together, and the name is a frame. We have defined a set of frame. NeTEx is providing some specific frames that we're using in that context, and we are subtyping them to fulfill the needs of the EPIP profile. So, for example, we have a EUPI stop type. So that's a specific type we have created for a frame, which is containing everything about stop place and site. And they have to be all consistent together and will be referred by other ones like the EUPI network, EUPI timetable, and EUPI calendar. So these are the frames we have defined for EPIP. And there are some generic frames also that can contain, a frame can be contained by another, but that's just a way to group things which are consistent with each other. And if you see the what we call composite frame, so the line offer is a line grouping of all the information, and we have another one which is network grouping. So we will be back on this later on, but so the recommendation is mainly to group information per line. A single file can contain several frames. So if it contains, for example, a UPI line offer, then this one will contain several, the command, the stop, the network, and the calendar for the offer, for the line offer. The recommendation is to stay at line offer. You may consider a network if the network is too big, but anyway, don't go larger. If so, you will end up with crazy huge files, which are very difficult to manage. So I'm not going to go into details of frame, but there's a few things I want to tell about it. A frame can have some defaults to avoid repeating over and over the same thing. Typically, so it can have a code space as a default, and it can have some frame default. For example, if you look at that local, you have a time zone, so you can give a time zone, and you will not be obliged to repeat the time zone over and over and say this time zone is for everything in that frame. Summary time zone, offset, default language, same thing. So that's a way to avoid repeating things, giving them as generic information at frame level. In NeTEx, now we are skipping to what we call type of values. In NeTEx, you have a lot of type mechanisms. So we have seen that we have some types of frame. Usually, when you look at an object, you have two things. You have object type and the type of object. The object type is usually an enumeration, so close to a limited set of choices of values. And then we also have a type of object. So type of stop place, type of scale stop point, and so on, which is an open-ended, so that where you can add some your own specific values. So there are all type of values here. So that this is generic. So the type is a convention with the name and the description and an ID. So that's quite simple. We have a very generic grouping mechanism. So we have explicit groups like group of stop plates, for example, but you can group any if you want group. We do have group of lines, but you can group whatever you want. If you want to create group of passing time or whatever, that's possible in NeTEx. So we have this generic grouping mechanism, which is described here, and usually it's specialized, so it's used by inheritance to create more specialized groups. Of course, NeTEx has geometry, so you do have points. A point has a location, which is mandatory here. It can have a point number and a projection. Remember at the very beginning I said that there is no infrastructure, so you don't have the road description or the rail description in NeTEx, but you can project on the road or on the rails. So any point can be projected through that projection to the road. So the road could come from GDF, from OpenStreetMap or whatever, or the National Road Database. So, but it's possible to project NeTEx objects on the infrastructure. Looking at points, the point has latitude, longitude, altitude, precision, and also what we call the GML. So maybe you don't know GML. GML is a GIS standard, ISO standard. So we have reused that standard for generic coding of position, including what we call here the SRS, which is the locating system. Meaning, if you have this, GIS will be able to read that GML position. So we do have points. We obviously have link. So a link is from one point to another point. One thing which is important, so the link also have a line string, which is kind of the geometry, the drawing of the link. So you can have a lot of intermediate point here in the line string, which is not in the link, is really from one point to the other, but the drawing can be much more complex. Link sequence, you can have a sequence of link. A zone have, of course, a boundary, which is a polygon here. It even can have holes. But one thing which is important, in public transport, sometimes you are not going to define a zone by its boundary, but by its content. For example, you can have a fare zone where the definition of the fare zone is just a list of stops which are contained in that zone. So that's also another way to define a zone without boundary, just by defining its content. And the zone has a centroid, which is usually one where you will put a pictogram, an icon on it. The mods in NeTEx are the mods we have introduced in the first presentation. I'm not going to be back on it, but we are quite comprehensive about mods, and you have sub-mods and modes of operations in the new version of the new extension for new mods. The alternative text is a way to give a translation to any attributes, textual attributes. So NeTEx provides two things: alternative name. So the alternative name is usually used for aliases, but you also have alternative text, which is to translate information. So you can provide it in different languages. A lot of the objects can have a color. It can affect, so presentation can connect it to stop representation, but to a line or any text. So this presentation contains the color name, the text color, the text font, so all the classical information, and also info links, which is typically linked to an icon that you want to use as the presentation for that object.
Christophe,
yeah.
We have 15 minutes left for this first part.
Okay, I guess it's nearly at the end. So we do have accessibility. I'm going to speed up a little bit. Accessibility can be applied to line, but also to service journey. So a service can be accessible, but the next may not be accessible because the bus don't have a palette or whatever. So you can have different accessibility at service level, line level, stop place, or key level. Typically, this accessibility is quite simple here in the profile. It tells if it's wheelchair accessible, step-free access, scatter-free, lift-free, have audible sign or visual sign. That's all, and maybe it's on off. You can say partial. There are some rules for when you say partial here, but that's very simple. So since this is very simple, that's why we also are working now on a specific accessibility profile with working paths, equipment, and so on, which are not in that EPIP profile. So that's the bare minimum of what is expected for accessibility. Facility set is the way to provide what's available at in the location or in a vehicle. If you want that to say that there is a bar or there are some toilets or you can buy some tickets. It will not provide the information on where are the toilets and how big they are and so on, but it will tell that you have toilets in that place or in that vehicle, and same thing for every facility you can have. The list of facility is at the end of the document. We didn't want to put it here, but if you want to have a look at them, yeah, that's there. All these, so it's quite comprehensive. All these are the facilities which are available from NeTEx. So if you only want to say low floor, or there's a defibrillator, or you can have snacks, or there's the post office. That's a way to say it. But that's simple. That's just a way to say there is something, or it's not here. It doesn't describe the service itself. Okay, so I'm done with this first generic part, and I guess we can go to the stop profile part of this document.
Okay, thank you, Christophe. Can you see my screen?
Yeah, fine.
Good. So the stop profile, I will not go through the document here. I have some slides instead here. So, but this is following the structure of the document. So stop profile describes stops for any mode of transport and the related properties. If we start with stop places, a stop place represents a physical stop or a station. That's one object. And a key represents the physical point of access to transport. And typically stop place could be something like a station with multiple keys typically. So You also have entrances to the station, stop place entrances, which could be the doors coming into the station. It could also be internal doors of the station. One should not confuse these keys and so on with scheduled stop points, because this is the representation of the stop in the timetable. So a planning software could use their own identifiers for representing the scheduled stop points where they're going to stop for a bus line or a rail line and so on. And different operators may have different identifiers for this. But the good thing here with NeTEx is that as we have the physical stop represented as a key and the kind of usage of it, representation of it as a scheduled stop point, then you can link these two together. So there's a specific object called stop assignment where you can say that this scheduled stop point is the same as this key. So for the stop places, we have the stop place itself, a key, entrance, and it relates to the scheduled stop point. And we have this mapping here where we can map a certain key to a certain scheduled stop point. It's also possible to work on the level of mapping a stop place to a scheduled stop point. So if you want to represent this in UML, you get a diagram like this down in the right-hand corner here. We have a stop place that contains 0 to many keys. And in the other direction, a key is in a stop place. And you can also see that the stop place can be entered through 0 to many stop place entrances. And you see there's a possible passenger stop assignment to connect and link a scheduled stop point used in a timetable with a key describing the actual stop. So in EPIP, we have a specific hierarchy. We only allow 2 levels of stop place. And I'll explain this better in the next picture, I think. We want to cover the case that you may have a stop which do not only cater to buses, but maybe also to metro and to trains. And EPIP allows this separation in saying, yes, we have this station where we have buses, metro and trains. That's the general stop place. But we can also say that we group these keys, these platforms for the different modes. So we have one stop place for buses, and then we have another stop place for the trains and a third stop place for the metro. So in this way we can group them, and then we at the same time have these individual stop places per mode and then one general stop place. And you can use any of these to refer to this stop really here. And talking about the keys, these are the platforms or gates where you actually board your vehicle. But the keys themselves can be in a hierarchy. You could, for instance, have a key that is the platform which lays between 2 tracks of the metro. But then you can have specific keys for the platform edges. So then you have one key for the track 1 from this platform, and then another key for track 2 from this platform. And they are both children of the key representing the platform as a whole. Okay, there are more types of place than stop place. There are also topographic places, and that is to represent the named settlements like cities or towns that are related to the public transport data. You have postal addresses and road addresses, and then have something called point of interest, and that represents a well-known attraction like an amusement park or maybe a church that tourists will go to. So going down in the XSD, we can see that the stop places, the points of interest, the topographic places, and some other things are organized under the site frame. And this is, as Christoph said earlier, this is the coherent set, a coherent set of data related to these type of objects, having the same type of validity condition. Yes, so the stop place, you have the entrances into the topographic place reference, where you can say which city you're within, for instance. And under stop place, you have this stop place type, and in EPIP, this is mandatory. And actually, these pictures I'm showing you, they are from the XSD that is specifically adapted to EPIP. So the comments here are in relation also to EPIP. So for the stop place, you can say what stop place type it is, if it's general or if it's monomodal. And then you have the keys. As you remember, these are like the platforms, the individual platforms. Sorry. Here we go. Key. And for a key, you can say that the place is a platform stance or quayside where passengers have access to public transport vehicles, taxis, or other means of transportation. And the key may contain other sub-keys. And you see here the circle parent key ref. This is how you can say that this key has a parent key. It's part of this key. Okay, and then we have the topographic places. And this is, here we can form sort of a gazetteer if you want to, listing towns, cities, villages, suburbs, and so on. And in EPIP, we have limited the description of topographic place descriptors to only contain the name of this place. And of course, if the name is a name that is used in many places, you can also use a qualifier to make this more understandable in what context this name is valid. And then we have the points of interest, and important to know that in EPIP, mainly the definition of the point of interest are supposed to come from some other source, but to this level we have included it in EPIP. And then we have tariff zones. These are the zonal fare structures for a zone counting or a zone matrix system. And what is a bit special in EPIP is that even though in NeTEx in general, you could under tariff zone define which scheduled stop points are included in it, this is not allowed in EPIP. Instead, you need under each scheduled stop point to say which tariff zones it's included in. So these kind of clarifications narrows the possibilities, but it also makes it a lot easier for the different parties involved in trying to understand information. So if they only have one way things are described, it's much easier than when there are multiple ways of doing it. So that was it for the stop profile presentation.
Thank you, Ulf, and thank you, Christoph. So this concludes this first part around the EPIP. We are just on time according to the agenda. We have now a short break, but just before, I think there is a request from Anastasia to take a group picture. So if you all agree, we would like to ask you to open your camera.
Yes.
Try to take
just a moment, I need to allow the cameras on. So
okay,
now,
sorry.
So now we can all open our cameras, so please open up and we will take a short picture. Just a moment. Okay. Thank you. Thank you very much.
Welcome.
Thank you all, and we will meet again in 10 minutes. We restart at 3:30.
See you in a while.
Okay, welcome back. It's 3:30, so we will now continue with the presentation of the EPIP with a focus on network and timetables, common rules, and profile compliance and data quality checking.
Okay, so you should see my screen now. So back to the document of the EPIP profile. So we start with the network and timetables. That's the biggest part of the profile. So I'm not going to go into all details there. It would be too long. If you have some questions or you need some details on some features, please write questions on the chat, and I will answer them at the end of the training. So here we are starting with a global view of what the network topology is. So this is basically what Front model is offering, but that's kind of a simplified view. At the center, you have the line. So the line has primary operator and can have secondary ones on the left. And the operator is usually connected to an authority. There are some different cases where the authority and operators are kind of merged, but we can manage this case too. But that's the more frequent way of doing. The line has a vehicle mode, so the same thing. It has a main vehicle mode, but there's a primary one, but there could be some secondary one. It, for example, sometimes happens that you have a train at most of the time, but at specific times or under specific conditions. There's a bus replacing the train, so you may have several modes assigned to line. The lines can be grouped together, so you can put several lines together. One of the most famous way of grouping them is to create a network, but the network is just a specific group of lines. But you can create a group of lines being all the lines operating at 9, even if it's across several networks or several operators and so on. And the line is running on the route, so the route is defining where on the infrastructure that line is running. So it's a set of points on the road or on the rail that is defining the path along which the vehicle will be running. So this is typically the route, which is defined by a set of points of route and what we call route link, so a link from one point to one point. But be aware that this route point may have no link with sub points or whatever. They're just defining how to go through the network. So these are the basic concepts we are having here. That there are, of course, more detail just after. So if you take a line, nothing very special. So remember that all our objects are inheriting from data managed objects that we have presented before, meaning that you have validity conditions, you have roles assignments, and you have versions. So everything we have described before is valid for a line. Then you have the ID names, the set of this description. Remember that this description can be translated with alternative text if needed. It has a public code, a private code, URL, a lot of attributes. I'm not going to work through the details of all of them, but that's quite a comprehensive description of what a line can be. You can tell if it's monitored, so if it has real-time information, typically Siri information associated. And here you find the link to the routes, the points which across which it goes on the infrastructure. the presentation. So I was talking about it before. So the color and the fonts you want to use for that line. Accessibility assessment, we also talked about it, so saying how accessible is that line. Some direction and the notice, will be back on notice later on, but it has typically a note which is associated to the line and which is something that is expected to be presented when talking about that line or passenger information. This is a group of lines, nothing very special, but just a way to put them together. It's a group of entities, so same thing, you don't see all the attributes here. For example, you don't have the description, which is in the group of entity from which it inherits, and the network, which is just a specific group of line with a name, and that's pretty much it. Operators and authority, they are both organizations. So we do have a generic organization concept coming from Transmodal, and an organization can be, in the context of EPIP, it can even be more refined if you go to a new mode, for example, but for EPIP, it's mainly either an authority, either an operator. Having a name, a number, a legal name, so still alternative names, contact details, that's important. In contact details, you will find the email, their physical address, and so on. And organization type here, which is mandatory for us. So you see an organization can be authority, operator, rail operator, freight operator, statutory body, facilitated operation, travel agent, service organization, or other. That's quite comprehensive. And then you have in the profile some details about operators and authority, but nothing. Yeah, to talk about. Pretty simple. Then you have the route. So the route is basically based on route point. Also consider that you have that specific border crossing, so that it's possible. You remember that we are at a European level. That's something you often will not find in national profiles, but since we are here at a European level, it's quite important to have that border crossing to tell that a specific route is crossing the border at some point. That may not be a sub point of whatever, but that's the point where the route is crossing the border. Each route link will have from point to point and the distance. So that's a link for the same kind of link we've seen previously. And the route itself is basically a collection of this, the link sequence of a collection of these links. It has direction ref, so which is an object in the direction of which it's running. And it can also, which is important, refer the reverse route. So there's way and way back. So this is a way back route, which can be referred to, from a single route. I'm not going to define the point on route and so on. So once you have this group of line network and route, so you can find here back the line at the top and route here, then you can start defining the service. So the first thing is defining a service pattern. The service pattern is typically the list of stop points that will order the list of stop points that this pattern will run through. So in a single line, you can have a direct train from the first stop to the last stop without any stop in between, but you can have also on the same line some omnibus bus or trains that will stop at every single stop. So on a single line, you can have several patterns, and the service pattern is defining at which stops the journey will call. So obviously, for one pattern, you can have several journeys. So on the same pattern, you can have one starting at the morning at 7, but then another one at 7:15, another one at 7:30, and so on. So you will have a set of service journey, and you can have a sequence of different patterns also. One thing which is important, that when we are talking about stops, as Ulf has described, the physical description of the stop is the stop place, but the topological description of it is what we call the scheduled stop point. That will be assigned to the stop place, the physical, but this is really the topological description of it. which is named here scheduled stop point. So you may find the name weird, but we didn't want to call it stop point because so many people are talking about stop point and have with different meanings. So when you hear scheduled stop point, you know what it is. It is the topological description of the stops for NeTEx transfer and series. And you have connections to go from, so you can start from one line, go to another, and there will be some connections, or possibility to go from one to a light at some point, walk a little while and board to on another line at the other connection end. And we here have some on the service pattern and the journey pattern here. We have some displays, which is basically what will be displayed on the vehicle, and that can change over the course of the journey. So this is a destination display, and if you have branches and some, it may change. You may display some via, or you may have some variants also associated to it. But that's very important for passenger information. Sometimes you may see that here we have two lines, so choice with A and B with the name here. When you have A and B here, that means that in NeTEx we have a choice between two possibilities, and A here is not filled, meaning that in the profile we only have chosen the second version, which is so here the name. I don't even remember what the A possibility, but that means that there were. But it's not that we missed something, but that this part is not selected, so it's hidden. And you may have the destination display variant. So a destination display can have multiple purposes. It can be displayed on the vehicle, but it can be printed. It can be designed for text-to-speech, for web, for mobile, or others. You can have not one single destination display, but several of them, depending on what you want to do, and also side text or front text for the vehicle. So this is a description of the service pattern. So the list of stops. So you see that service pattern. So there is a route, the direction display, but the main thing is point in sequence, which are the stop points in that journey pattern. The direction. So it's not the destination here. So we have a direction giving if it's south. North, inbound, clockwise, outbound. So that's generic information about the direction, not the destination. But you do also have a possibility to provide the direction when needed. So this is the point in journey pattern. So the list of points we're going through with the destination display ref for that at that point. Not that we do have some flexible property already available here, meaning for transport, for on-demand transport, we do have information at stop level, and this will also contain information about contact information, so how to require the bus to come to that stop and pick you up if it's on-demand, so if it's flexible. So the stop point in journey pattern, yeah, so it's obviously a point in journey pattern, and it's also a timing port in journey pattern. That's multiple inheritance we have from transmodal. A timing point is the point which is designed for defining the timing. Timing point may not be stop points, but in the context of EPIP, we only have used timing point when there are some points. It's a specific choice. And we still keep this information because when a stop point is a timing point, the timing information is very accurate. That's what the EVMS is doing to manage and make sure this timing is followed. If the stop point is not a timing point, then it's kind of interpolated. There is no formal constraint to be exactly at that time, at that point. The exact time is only at timing point. So that may be an important information for passenger information. So on that point, you will know if it's for boarding or lighting. So at sometime at some point you can only go out or go in, depending on the top or the service. Still the flexible properties. Notice assignment. So once again here, we find a possibility to add a specific notice. So something, a text that will be presented to passenger associated to that stop. You will know if you need to request that stop or if it will be systematic and so on. And booking arrangements. So you see this is also clearly connected to on-demand transport, where you have for that specific stop all the booking method, booking access, when you have to book, if it's in advance, it's 10 minutes in advance or whatever, latest booking time before the passing time, booking URL, booking not. So all the information you need about booking is available here. And you have the scheduled stop point, which is the main object we're stopping at. So you still having that inheritance, like being itself timing point and so on. It's on the tariff zone, so that's one first place where you find information about tariff zone. So the scheduled stop point is can be within a specific tariff zone. It has names and so on. It has a type, so you can already say if it's, even if it's not the physical description, say if it's an airport, a bus station, a harbor, a ferry port. So you start giving some information about what type of point it is. And you find back the timing point status here, telling you if that stop point is or is not the timing point. The stop assignment. So remember from what I was explaining, we do have scheduled stop points and stop places. And then, so that scheduled stop point you are describing can be assigned to any component, any stop place or component of stop place. So that can be, if you know it's a specific key, but sometimes, for example, in France for rail, we have a late assignment of the key for the train. So at first you will provide only an assignment to the stop place, and later on you may provide a dynamic assignment to a specific key. So you see here the link to the either stop place, either to the key itself. And you also have connections to train elements. This is specifically if you want to provide some details about where the train is and how it is built, the constitution of the train, and how it will, where it will stop, where its path will stop on the key. This is dynamic stop assignment. And so we, as introduced, we have some specific information for the train. You probably know that for train, you may stop on specific area on a key, and even you may have, and that's not the case in France, but that's the case in Switzerland and Germany, you can have two trains stopping at the same key and going into different usually opposite direction. So that's using that kind of object train stop assignment that you will solve and provide information for multiple trains at the same key. So the service link is very simple. So link to the service pattern, so the list of points from where you are going to. So it's a link from one scheduled stop point to another one. Very simple. The connection is that we have a generic transfer information. So the fact that you can walk from one stop point to another, where you will have the distance, the walking this direction, telling you if it's both ways, and also some transfer information, so like the default walking duration, but also for frequent traveler, if it's shorter, occasional traveler, if they need to read the information, or mobility restricted duration for wheelchairs and so on. So this is a connection between two stop points. But we also do have something named site connection to connect a stop point to a site. So a site is typically a point of interest. That could be parking. That could be any administrative place you need to go to. That can be the swimming pool or whatever. So you do have also that way to describe the connection between public transport and all the point of interest which are around. So that's an important object also, and that makes the links with the point of interest that EPIP was introducing. The default connection also, we do have this. Sometimes for journey planners do need to have a connection time when you are doing connections, but sometimes you don't have that information. In such case, you can provide a good generic information saying if you are connecting between two metro stops, for example, it's going to be 5 minutes if you don't have a precise value, and it's going to be 7 minutes for a bus or whatever. So that these are default value to be used when you don't have the detailed connection time. And now we have the passing times. So we still have our service journey we were talking about. So for each service journey, you see here it has timetable passing time. So we only have what we call the timetable, the scheduled passing time. If you go to Siri, you will have the estimated calculated by the AVMS and the observed. But so in NeTEx, it's only the estimated, the timetable passing time. So you will have the notice also assigned to the journey. And in addition to the connection, you can have an interchange definition, meaning that it's really going to be a service connection. So the bus starting at 7 o'clock in the morning will at a later stop connect to another bus, which was the one starting at 7:30. So that's really between two services, not between two lines or two stops. And these are the passing times, but we do also have headway services. So you can define the headway frequency for definitions, so saying to tell that you will have a metro running every 10 minutes, for example. So instead of providing passing time, you give a time slot. So from 10 to 11, you have one metro every 10 minutes, for example. So that's what you will find just after this. I'm not going to go into all the details of it. But for each journey, you will have its duration and, of course, the passing times. You have some things which are maybe specific to some modes. Here are the train numbers. It's obviously very important when you're talking about trains, but it's often used if you're talking about bus, of course. And you can split the journey in parts. We will be back to it. It's mainly useful for trains too when we want to split or join trains. And you do have flexible properties. Also, typically here, it's quite simple, but it's mainly to define virtual lines and have access to booking arrangements. It's not a very comprehensive and detailed description of flexibility of on-demand services, but that's the basic, which is most often used, in fact. But you don't have all the zonal and details around it. It could fit for zonal, but will not provide the details. So for passing times, it's important that the profile, so I'm taking advantage of this big note here. It provides a lot of details on how to use things here. For example, there's a typical use case where people have questions how to manage passing time when you have a journey crossing from summertime to winter time. It starts on one day and of the other, and in the middle of it, you have a time change due to winter to summer time change. So there's a way to explain here how you're expected to manage this. So in that case, everybody will do it the same way. And that will obviously ease interoperability. So passing time, the passing time has an arrival time with an offset. So that when you're in for example, on distant bus, it can run several days. So the arrival time can be on the day you're running, but it can be also the next day or two next day if you're running for 1,000 kilometers, for example. So arrival time and departure time and possible information about headway frequencies. Vehicle type, of course, every single journey will have a vehicle type associated to it. So this is the definition of the vehicle and the characteristics of this vehicle. So the type of fuel, the capacity, how many passengers you can have inside, but also the fact of having a low floor of a lift or how and the size of the vehicle. And we have a specific vehicle, which is a train, where you can define the train itself and its components, the main engine and all the after the train elements. And you can order them and then have a description and tell if it's one element is for train element is for specific fare class. So you can have one first class and one other second, and so on. So you have here all you need for this description. Headway frequency. So as said before, you can say that you will have a bus or a metro or whatever running every 10 minutes. So you give the first passing time for the first run time for this journey, the last departure, sorry, that's the journey itself, and yeah, and you give a reference journey also, which is important. You will provide information to template journey, so you will know what are the run times. So you have a template to tell. So you know every stop is every 10 minutes, but you don't have the time between each stop. So the template will give you the time between all the stops. So this is here the template vehicle journey. So that's a typical journey, but it will replicate over and over every 10 minutes in my example. You still have the grouping service interchange. So I said before, this is between two vehicle journey at a specific point. So nothing particular, but it does connect really journeys, and that's where usually you can have guaranteed of connections where the operator is going really to wait from the other to be here before the vehicle is going to leave. Some information which may be interested also sometimes. If, for example, you have a bus doing a circular journey, so it comes back at the beginning. So in that case, you don't need to make a connection by going out and going back. You can stay seated inside, and there is a set of situations like this. So the notice, I already told about it. We already accept notice in EPIP, but that's not for global NeTEx, but in EPIP, the decision was to put them on service journey, point-in journey patterns, and service journey interchanges. So this is typically the notice is still inheriting from the data management object, having a public code and a name, and of course the text, which is the text which has to be provided to the sender. Of course, it can be translated in multiple languages thanks to the alternative text. That's one of the typical use of alternative text. And so you see the notice assignment. The assignment, in fact, can pretty much assign the notice to any NeTEx object. So as said before, in the context of EPIP, we have decided to limit the use of notice to a set of objects.
Christophe, we have overpassed the time for this part, so if you can move ahead.
Yeah, I think it's nearly over. I'm not going to detail here it is as a train composition and train parts. As said before, you can model the fact that you have trains splitting and joining, so you can now have two trains starting from two cities, joining at another city and ending as a single journey. So that's train coupling, and this is also fully described in the text, but that's only for trains. And yeah, we do have the calendar. So every journey run on a calendar. Typically, that's from a day type. So you have a day type, and the day type is within the calendar. So the day type can be every week, every days of the week, only on weekends, Monday to Friday, or on only Wednesday, whatever, and have a period on which is mainly it's running, which is operating period here. So you obviously can define the calendar for every single of them. One thing we also have decided in NeTEx is to also always provide for journey planners a bit field, so 0, 1 from the first day of the validity period, saying the 0 says that the journey is not running, and 1 says that the journey is running. This is for each day. So you may already have seen this for journey planners if you're familiar to them. But a lot of journey planners expect the calendar as a bit field, so that's also a possibility here. So since I'm late, I'm not going to detail more here. I think that's all for this part. So that's all about and flexible service. So that's part 8. But there's nothing. That's just the flexible line here, saying what type of flexibility you have, and mainly reusing the booking arrangement that we have already seen, and the possible flexible information at line and journal level. So that's all here for all this part. So that's quite a lot of information. So feel free to ask some questions if what to pass on some point.
Okay, I will continue. Do you see my screen?
Yeah.
Yes.
Yeah. Good.
Yes.
So I'll try to rush a bit forward here because I think we're a little bit late here, but I think we'll manage.
Sorry.
So the common rules of EPIP, it concerns these areas, typically version management, validity conditions, the ID structures for objects and version frames, the responsibility for data, and also some points about handling large data sets, data exchange, and file naming. So beginning with version management, Christoph was already into this, but it's very important that all objects must have a unique ID. And for EPIP, there is a defined structure. I will talk a bit more about that later, but this is an example of an ID for an object. This is a specific scheduled stop point. And this ID should be persistent throughout the life of this object and any successive exchanges. We should see the same name over and over again. So we know that it's the same key, for instance, we're talking about. And if you do some updates, change the name slightly, remove the position slightly, you shouldn't change the ID. Instead, you provide the object with a new version number. And to be clear, if you change an attribute value of an object, you need to create a new version of this object. If you change a reference within that you use in this object to another object, you need to create a new version. So a change to a reference requires a new version of an object. A change to a subcomponent, I mean, an object can be complex and contain children and parts. And also in this case, you need to record this as a new version. As said previously, a set of objects are contained within a version frame having the same validity condition. So you have, for instance, all the stop places within one city is maybe one version frame, or all the service journeys for one line is one version frame or similar. And if any object in a frame is modified, then the version number of this version frame should be incremented. And all the versions of objects within a version frame, they shall be coherent. So if you get an export, you get a specific version of this version frame, and all the data in this delivery should be consistent, and so you can use this as a whole. So different sets are organized into different version frames. As I mentioned, for example, the service journeys for one line. So you give it an identifier and you retain that for that line over time. So here we have an example. We have line 91. And this identifier will be retained all over the lifetime. This doesn't mean that you can't change the information. You will do that over time, but then you will just send new versions having the same identifier. And of course, some of you, do we need to go down to handling versions in our systems in a very complex way? No, you don't. It is possible to work also with the snapshot type of export, but the IDs must be retained, and at the minimum level, you need to show that if any object in a frame is modified, the version number of the frame itself must be incremented. So you can create successive complete version frames with the current view of all your objects within. That's okay, because then the frame itself versions the objects within them. Of course, this limits how you can use your data, but it's still a way of doing this in a way that works together with more advanced versioning mechanisms. Coming to validity, Christoph already mentioned that we only support a very simple validity conditions on objects using the valid between concept. But to start, the most important is to be able to define validity for the version frame as a whole. So you could produce one document for line 15 that is valid until the 11th of December. And then you have, for the same version frame, a new document for the public transport after that date. So you can deliver these as two separate documents for the same version frame, but having different validity conditions on them. So the ruling validity condition is this one that is placed on the frame itself, and it must have a start date at least. And just to be clear, when you deliver a frame, and then you deliver another frame that partly covers it, then the later delivery wins over the first, if there's an overlap. So the ID structure in EPIP for objects is according to this. You have a country code. You may have a local code if you need. You have an object type, a technical identifier, and if you need, you could also have a specific additional ID to separate things that otherwise would be equal. So in this case, I take this from my example document. You have LU for Luxembourg, you have scheduled stop point, that's the object type, and you have this 2138047 AVL as the technical identifier. And when we don't have any information, we keep the colons, but we just leave out any information. Okay. Similarly, we have for the version frames, we also have an ID structure, and this is defined in EPIP like this. You have a country code, optional local code, a frame type, the EPIP type, and the frame topic. And the frame topic could be like line 91, for instance. Okay. So the responsibility part, Christoph was into this, we may have a mixed environment with multiple operators and maybe multiple authorities even. And it's important that we always indicate in EPIP a responsibility for who is providing the data. But there may be also multiple providers referenced here in this data. But as we said, at least on the outermost container frame, you must have some sort of responsibility. And the operator or the authority that provides the data must be specified in the EU PI common frame. Now to handling of large data. If you try to express all the data according to EPIP for a country, it becomes a very, very large file. We strongly suggest you try to separate your delivery into multiple files. Otherwise, you will end up with extremely large documents that will be very hard to handle for validation and for using systems. So please try to consider if you should have a division into a line concept or something similar when you divide these files. So for the data exchange, you exchange XML documents typically. In EPIP, this is an exchange of files. And for example, you can have the EU PI line offer way of doing this. And this means you deliver one line and then you describe the stops topology and type tables related to this line. And this, of course, means that there might be an overlap because the same stops might be used several times. But this is the way how it's done in EPIP. You will be able to, having this very clear mechanism with the identifiers and versions and so on, be able to resolve this in a later stage. But in this way, you get a complete information in one document. There are other mechanisms possible. You could deliver the complete set of lines or a number of lines in a EUPI network offer. That's possible. And you can also just deliver the stop information in the EUPI stop offer when this is a relevant delivery. So again, we have a recommendation here for the naming of the files when you export these XML documents. So this is a suggestion in EPIP. So I have an example here, and you see yourselves how it's built up. Now over to profile compliance and data quality checking. So when you want to check if your data is good, you should start with a standard XML validator. There are commercial ones, and I think there are some open source possibly available. I typically use XML Spy myself. And then you should validate your XML document using a tool like this, and you check it against the NeTEx publication XSD. It must validate against that, otherwise it's not even NeTEx. Data4PT has developed some artifacts. I will talk a little bit more about them later, but that means that there is actually also an XSD schema that fulfills the EPIP, which is much stricter in certain aspects than the NeTEx itself, and it's much smaller as well, which makes it much easier to use. And we have checked that if something validates in this XSD, it will also validate in the NeTEx document, but the other way around is maybe not possible. But XML validator is a good way to assure that you're compliant on one level, but there are, of course, other ways you can. We're looking forward to getting some products which are profile validators that covers other aspects of the validation than the strict XML XSD schema validation. You could, of course, also do manual inspection. So if we want to cover now the categories for checking, there's a number of different aspects to cover. We have the syntax conformance, and that we can do with the tools I just talked about. Also, referential integrity and uniqueness is possible to some degree do with these kind of tools. Then we have the general profile conformance, that additional data must not overlap or contradict with the content of any of the elements. This was also something Christoph mentioned, that you might create key lists with stuff that kind of is the same as something that is strictly defined. Look out, don't do that. Then we have common NeTEx semantic rules conformance. For instance, you must assure that all the times for a vehicle journey is in sequence, so you don't go backwards in time and so on. So all the departure times should be the same or increasing, never decreasing, for instance. There may be some specific profile conformance. For instance, we have restrictions of stop places not being nested more than 2 levels, and you can't have notices on everything, just on certain objects, as Christoph also mentioned. You also want to have the data completeness aspect. You need a coherent set of data. So if you refer to a stop, there should be such a stop defined somewhere, for instance. And then we have the data plausibility. For GTFS, there are some tools that can check, for instance, that the speed of movement required is not impossible. So, for instance, you shouldn't allow buses to have to move at 2,000 kilometers per hour to reach the stop point in question, and so on. And then you have the relevance question, data relevance. The data sets should be as tight as possible and avoid unused or not referred objects when not relevant. This, of course, can differ a bit. Maybe the stop is not used today, but will be used tomorrow. Well, then you maybe should send it. But if it's never going to be used, you shouldn't send it. The correctness, data correctness, that includes spelling, etc. Correct locations, not being at the equator and so on. Yes, thank you. That was a shortened one presentation here. And I guess I will continue with the EPIP XSD artifacts presentation.
Yes, please, Ulf. And that's also part of one question which has just been asked through the chat. So.
Yes. So do you see my EPIP XSD artifacts presentation in full screen?
Yes.
Thank you. Yes. First of all, there is a Data4PT website. We keep talking about this, but here in the guidelines, you have a possibility to download a presentation which is similar to the XSD schemas that you can see in XML SPY. It's a HTML version of that. Quite helpful if you want to browse through the XSD that is adapted to the EPIP. Then you can download this EPIP adapted XML schema also. And there's also an EPIP example file, a very simple one, but it shows you how a valid EPIP file looks. So there's a set of adapted XSD files implementing the NeTEx European Passenger Information Profile. There's also a slightly extended version of this that, in addition to the EPIP, also includes some other real-world use cases based on a number of files collected from around Europe from different operators and authorities. And as I said, there is also a simple EPIP example file based on a modified Luxembourg export. So with this data, it's supposed to be able to help you with EPIP compliance. And actually, the full NeTEx XSD set is very hard to use if you want to generate code. There's a number of shortcomings there. While this reduced set is possible to generate C# code from, which could be useful if you do your own validations and stuff. The experience shows that it's very challenging to start from the full NeTEx schema, and here you have a smaller version that is more focused on what specifically needed for the EPIP. And also the auto-generation tools that are available from Microsoft and some open source tools like MGNSS works very nicely with these new set of reduced XSD files. So instead of the 379 files on NeTEx, these are compressed into simply 4 files each. So you have the EPIP set of files, and then you have the reduced file of sets, which, as I mentioned, is a bit wider than what the EPIP itself covers. So what is done in the first set of data, elements and attributes have been removed. The underlying XSD has been restructured, and things that are mandatory are set as mandatory according to the official SEND technical standard. So the second set, it's quite well covering most parts of NeTEx, though not all variants, but the variants we found used. However, it doesn't cover the fares part for now. Otherwise, it covers very much. And as mentioned, it adds the vehicle schedule frame also the call structure, things that we can't see in EPIP. And the method was to analyze a number of XML files from Norway, Netherlands, and other countries to try to see what parts are of interest to be covered. And it's all been flattened into 4 files. So some parts of the full schema complexity was rewritten, and others were removed, and others were replaced. And there was also applied a set of verification XML files to show that XML files that are valid according to this XSD are also valid according to the full official XSD of NeTEx. And as I mentioned, we provide a simple EPIP example document. It's quite useful if you want to see how to define your own documents. You can look into it and see a number of constructions and maybe better understand the text of the EPIP using it. And when you create your EPIP XML, it might be easier to use this specific XSD as a starting point compared to use the full schema. And when you created an EPIP file, you should, of course, validate it towards the official NeTEx publication XSD for safety. And then you can validate it towards the EPIP XSD. And of course, there may be additional tools that help you with aspects of validation, as mentioned previously, that are not covered by these kind of applications. So again, you can find a lot of more information on the website and the wiki. Thank you. So maybe I continue also with the technical examples, and then you take over after that, Christoph. Is that fine?
Yeah, fine for me.
Yeah. Just a second. Do you see this full screen, technical examples?
Yes.
Yes.
Good. So I want to give some examples, and I will start with Norway, NTUR Norway. They have open data that's easy accessible. You can go and download NeTEx or GTFS if you want to. And if we push the button and download Møre and Romsdal, which I'm familiar with, you will get a zip file with a lot of XML documents, one for each line, and also some other. So if you go into this document, you open it up, and you can see that this is not EPIP, but it's still very well configured profile here. And you can see here that in this case, this is a Series ET file here. You can see here the dated vehicle unit reference, how it looks. And you can see the aim departure time in the ET. But now we're talking about NeTEx, and you can see that you have the exact same identifiers for this service journey and the exactly same departure time. One very important aspect, ensure that your NeTEx information, the serial information use the same identifiers. And actually, we're showing 2 aspects. This is what you get. The current picture is what you get from the NTUR site if you download it. But this is what the local fylke provides. So this file was provided from the region to NTUR, and then NTUR did some minor tweaks to the data, and then they published it. And you can see it's very similar, the information you see in both cases. If you do a nerdy comparison between these two files before and after they came to N2. You can see there are some small differences. You can see that N2 removes projections. Here we have point projections from stop point and journey pattern to which timing points the scheduled stop point is attached. While this is not available at N2, you can see the structuring of information is a bit different. There's not mandatory in which order you provide attributes, for instance, for elements, and this is not retained. So that doesn't matter really for any technical systems. The versioning information is removed. There's a number of small things, but in general, not a lot of difference. Could possibly show also let's see. This. Can you see my Windows Explorer?
Yes.
Good. So here are the documents that we provide on the website. We have the XSD files, the EPIP XSD files. So if you open one of these, we have both a constrained version where we show that all IDs are included, and we have the no constraint version available. And you can browse and see the different objects here and go down into detail and check down to a very low level here. So this is adapted to the EPIP and what is allowed or not. Here we have a service journey. Here we can have notice assignments. And in this case, the notices provided. And so on and so on. So that's what's available there. And then we have the example file. I think we can open with XML spy. We can to the grid here and look out. So here you see a lot of information that we need to define code spaces for EPIP data, for instance, for EPIP metadata.
Sorry, Ulf, we don't see the file. We see the Explorer.
Oh, my error. Sorry. Thanks for pointing this out. Is this better?
Yes.
Can you see? Yes.
Yeah.
Yeah. Sorry for that.
Thank you.
So here you can see the code spaces. For instance, we have the EPD, which is the code space for EPIP data. We can go in and look on the timetable frame. We can see the vehicle journeys, and we can check specific vehicle journey. We have the transport mode, the departure time. We have the date types here, the date type ref. And we can go to the service calendar frame and look on this date type. We see we have a specific date type, and then we can see the operating periods for this. And as Christoph mentioned, in EPIP, we're supposed to provide a valid day bits sequence here, showing that on which one means runs on this days and series does not run on this day. So this is how the calendar information is in this case. Okay. And we can see more things we have in the resource frame. We have responsibility sets, we have roles. Yeah, there's a lot of things here. But this is all public available, so you can go and browse through this data yourself if you want to. And We can just look in a little bit more in the service journey here. So we have the service journey pattern. We have the vehicle type. I think I will go over to the text mode here. And the number of information, we use the passing time concept here. Departure and arrival times. Then this is, again, it's a very reduced set to make it easy to view. It's just 2 vehicle journeys here, but it's based on real data. Okay. So now we have 1 minute, Christoph.
Okay. So I will just give you a quick overview of another example here, which is the example of Île-de-France Mobility. It's interesting because it's quite comprehensive, and they do have reference data sets for stops and for lines, so reference database for stops and lines. So you can see them on the screen here. So here, that's the page, open data page, so that everything is freely available. You can connect to that site and get the information. They also have a very comprehensive documentation that's here. It's interesting to see also because I'm not going to show you everything here, but it tells you that the scope of Île-de-France Mobility, so that's all public transport around Île-de-France, around Paris. So that's 85 operators, nearly 2,000 lines, and 40,000, quite huge. And provided in France with the quite detailed description of everything. Typically here you find like the description of stops, so they have their own naming, but that's stop places and keys. And what they call the VDL is a mono model stop place, where this one is LDA is multimodal. So you have a lot of example here, and so if you download this file, this is stop file. So it's a big file. So I said that's 40,000 stops, quite a lot. If you look at the file itself, if you can see my browser, the XML file is 174 megabytes. But in fact, what you're extending when you zip it, and that's why when you put it to HTML, it's a little less, about 10 megabytes. So you see it's highly compressed just with a simple zip. That's one of the important points. And if you look at what's inside, you remember we talked about group of lines. So there's a first frame here, the general frame, and maybe I make it bigger. And so you have a set of group of stops. So you say they define something named Paris Est with 3 stops, something named Lambeuse, Boulainvilliers, and so that these are main points where people may be interested in going to in Paris. Then you have the stop places. So they define some very simple stop places. So you see, it's not a lot of attributes. I take one. That's a simple block with a name, a location, with a point there, an address, and the type of stop. And this places will contain keys. And for either possibility, the most detail or at key level. So this is the key. Just fitting on one screen. Say. So that this is one key with all its information. So with the centroid, which is the one point representing the full key, the reference to the stop place, the postal address, accessibility assessment. Saying so here it's a number, but sometimes you have some details. You find the limitations here. Type of transport mode and destination display. So all the destinations that can go on that line. Here it's only one of them, but sometimes you have 40 different when you're in Paris Center. So this is the list of stuff. Sorry. You have the same thing for lines, for a line, they use it also when they are doing call for standards. They use that line reference data set. So they define all the operators. So the 85 operators I was talking about are here defined as organization unit. All the notices we're talking about are also defined here. So you see that there are big files, but not that difficult to read. And this is a line, so starting here and yeah, and ending here with the notice assignment. Yeah. So with the valid between, you can find that this is not purely EPIP. In fact, it's compliant to EPIP, but it's a defined local profile, which is based on the French profile, but which is more or less aligned with EPIP. And they took a subset of it. For example, they removed so in the possibility they don't have long distance train, it's just a region, but they don't have long distance train. You can see the K-list I was talking about, and these are for alternative identifier, as I was mentioning, maybe to connect to ticketing systems, and then you have the name of the line, the transport mode, a private code that is internally used by STIF, the presentation, so the color of the line on the that you should find. The alternative representation sometimes an alternative accessibility assessment. The thing is here it's unknown, but you have the wheelchair audible signal and visual. So this is mandatory to provide. It's expected to be yes for everything, but here it's not even known. And the notice is notice assignment. So that's quite simple. There's one example I will provide it later on, which it will be with the material from the presentation. I'm not able to go into detail. I received it this morning, but it's interesting because it's also show you other way of using NeTEx. If you look for mod, for example, here don't get mod. It's for cable cars in stations. So it was kindly provided by SBB, and I don't know why I can't find mod here. Anyway, and that's a comprehensive example with all the types of values. You can see here the organization, the stop place, the lines, and timetable. That's also interesting to see different kind of usage. It's not only about extending the full timetable on a per line basis, but you saw from Ile-de-France Mobilité that NeTEx was used for the stop place repository, the line repository, and here it's used for other modes for cable cars in more specific context. So NeTEx is really well suited to be used in a lot of very different situations. Okay, so I will stop here for examples. Maybe I just can have a very quick walk through the reference to end the presentation, the reference links and documentation. So the official NeTEx documentation has to be purchased from your national standardization body. It's the same time for EPIP. I would encourage you to Google things like NeTEx EPIP profile, and you may have good success in finding something. But usually you're expected to be bought from national body. Some additional resource, of course, you have the DATA4PT site where there's the wiki. If I click here, so this is the DATA4PT website. I think that we have some more with technical support data model. So you have a lot of information that you can get from here, including knowledge database where you will find the training material also from today, but also from all the other ones we did, and the wiki page where yeah, you will have information on theory, NeTEx, and whatever. I'll probably be back on it just later. One thing which is important, which is a NeTEx CCN site at the official NeTEx website, so you can find a lot there. And if you're interested by the XSD or by implementation, of course, you need to go to the NeTEx GitHub site where the XSD is. About example, one thing which is interesting, so this is the NeTEx GitHub side. So here you find everything, including the XSD, of course, but also a lot of examples. Now that's important to keep in mind that we provide NeTEx XSD with a lot of examples. And in this example, we do have functional examples. So you click here, and if you want patterns or grouping or pairs or sub places, you just have to click. And here you have a set of examples of XML for sub places. And if you go to standards, you will find, for example, GTFS. So that's some GTFS files that have been encoded in NeTEx. Neptune, that's a French older format. Noptis for Sweden, Norway, SAP TSI for rail. So if you click here, you will find the SAP TSI conversion of to NeTEx of some rail files. So it's also important to know that in the official NeTEx XSD, you also have a lot of available examples that you can rely on to build your own system. The wiki from Data4PT, a French website which is quite comprehensive and where you can find a lot of resources, and of course the Transmodel website, which is a model on which we are based for everything in NeTEx theory and Opera. And this second slide, we provided a set of additional links to two profiles. So these are the French ones. Here is this NeTEx profile for Switzerland. This one is the Nordic profile. This is the German profile. This is the UK profile. This is the Dutch Netherlands profile. And this is a reduced XSD that was presented. There are some missing ones while we were talking. I received the mail from Italy, and they want us to add the link to Italian profile here, which is nearly finalized now, and also a link to tools. So there is one important enter. So for Norway, they have a GitHub which is very comprehensive with a lot of open source tools. I'm not going to walk through everything, but you here have a lot of development resources to manage XML files, including, you see, Open Trip Planner. So you may know that this drone planner, and they have integrated in the text imports in Open Trip Planner, and now that's officially reported by Open Trip Planner. They have the sub-drone database and so on. So a lot of information. En route, which also was doing which is maintaining and expanding the former Sweat tool, which is importing and providing and converting NeTEx information. Here, this one has mentioned Hastis. Hastis is one traditional schedule information system. And Stefan de Koning from Netherlands did a nice export, what we OIG, which is a scripting from Hastis, to extract the information from Hastis and provide it under the NeTEx format. So it's in the Dutch profile, but that's a very useful tool to start with. Open Trip Planner, as said before, converted GTFS to NeTEx used in France here. So it's these two ones, Ginex and from CS Group and Limiplan or commercial tools. It's not still sensing. It's not comprehensive. You have a lot of other tools. I know that there are some companies in Switzerland and yeah, of course, we can it. So just some first reference you can have here. So but you can realize looking at this list that NeTEx is already quite widely used and you can find a lot of resource or company being able to manage it. And so back that DATA4PT website quickly went through it already. And so remember that you have a frequently asked question, and you can ask question. You can request for support or for specific training on something specific. We're really here to help you on this, and the answers and the support we will do will contribute to enhance the frequently asked questions all the time. Okay, so I guess I'm done. We have something like 15 minutes for questions, I guess.
Yes, so thank you, Christophe and Ulf. So this ends the series of presentation for this training. So we still have 15 minutes left to take few questions. So we have already answered some questions around documentation and tools from the chat. So if there is any other question, feel free to ask. So I see one from Nils Asmussen. Google and other commercial maps with travel planner functions collects plan data from GTFS exports. Do you expect that Google and other will go for NeTEx as soon as available? And do you expect that they will add all features as soon as they are available in NeTEx EPIP?
Maybe I can answer to this. So GTFS is now managed not anymore by Google, but by mobility data. Of course, Google is involved in mobility data, but you have other big players like Apple, for example, involved in it, and a lot of US authority and so on. So it's not only NeTEx, Google anymore. We are working closely with mobility data to align things as much as possible. We will quite soon provide some rules to go from NeTEx to GTFS. That's something you can quite easily do. Of course, the stuff of GTFS remains quite simple. I don't think there is intention for Google to move to NeTEx. But that means also that they will have to stick on that simple way of representing the public transport. For example, they don't really make the difference between authority and operators, and so there are some evolutions these days. But that remains. They don't have a very comprehensive sub-place description that we have. And anyway, that's sufficient to properly fulfill the use case they have of doing journey planning. So what we kind of expect in the future is that in Europe and maybe other countries, everybody will provide the comprehensive information under NeTEx and the subset of it under GTFS. So existing tool already using GTFS can consume this information, provided they don't need more. And if they do need more, then they will have to jump to NeTEx.
Yeah, and to complete, I confirm that we are thinking to organize a next training around this GTFS NeTEx mapping. So you will be informed once this will be organized. Okay, is there any other question from the audience?
I could just clarify, we had the question concerning the XSD that is EPIP specific, and as shown in the pictures, you can download it by clicking in the knowledge database links. There you get the complete XSD sets as well as XML files.
Yes, thank you, Ulf. I can just also share the link. Okay, so you have now the link in the chat. Thank you. Okay, so we just get an additional question from Tuka Astrup. Are the lifecycle rules defined for stable unique identifiers? Which changes cause the old identifier to stay in use, and which changes cause a new identifier to be minted? Christophe?
Yeah, the idea is really to keep the identifier stable. Something so, as explained, we have the version mechanism, which allows to create multiple versions of the same object. We do know, I faced it several times in the different operators, that some systems try to change an identifier regularly. That's really not a recommendation. If that's something you can't avoid because you're on the legacy system and it will take time to make evolution, you can create links between objects and there's a specific attributes that you, which I don't remember the exact name, it's based on, so you can tell that an object is based on another one. But really a single subplace, for example, should keep one single ultra stable identifier. It's not expected that people will change it, and that's also one of the reasons why we often recommend to have a sub repository and a line repository. That's to make sure the IDs are stable. If not, it's really a nightmare, specifically when it changes and a lot of stakeholders are involved. So you can manage it, but that's very difficult. So, and the recommendation is keep identifier stable. I saw another question about putting EPIP in GitHub. Obviously, that's possible. We didn't discuss about it, but that's probably a good idea.
Yeah, definitely
Yes.
it is. So we will take care to include it in the GitHub NeTEx, of course.
And I see also a raised hand from Thibault.
Yes, you're right. So Thibault, you can maybe ask your yes, just
yeah, you can now unmute yourself if you want to ask a question. Thibault. If you want to ask a question, you can unmute yourself now, except if you didn't want to raise your hand and it was accidental. Now you can unmute. You can unmute.
I guess and we answer the question.
Yeah, so it was a question around the XSD on GitHub. Okay, that's fine. Any other question? Please ask in the chat or raise your hand to open your mic. No more question. So anyway, we also remind you that you can request anytime technical support on DATA4PT website. So I just share again the link in the chat. So feel free to use this link to request any type of support. Can be just general questions around the standards, implementations, national access points. This can also be more deep technical questions, or even if you wish to organize any dedicated training, even in native language. So feel free to ask, and we will make sure to provide you some answers or relevant proposals to support you in the implementation of Transmodel Siri and NeTEx. So to conclude, yes, just thank you all for joining this new DATA4PT training webinar today. So we really hope that it has been useful for you and that this will help you in your ongoing and coming implementations of NeTEx. That's really our main expectations, to share knowledge from our experts team to guide you, help you in such interoperability and deployment of national access point and related mobility data. We already invite you to stay connected on a Data4PT link in channel to be informed of coming events. So in the coming weeks before summer, we will share the next milestones and dates for the coming events, including coming trainings. A big thank you to our speakers today, Christophe and Ulf. Again, very well done job. Big thank you also to Anastasia, who prepared this training, and Pascal, who is in backstage today. And also big thanks to UITP team, Charlotte and Sylvia, for the registration process and all the communication management. All the related material, recording and slides will be made available in the coming days on Data4PT website, and you will be informed, of course. So thank you again, take care, and enjoy the rest of the day.
Thank you very much.
Thank you. Goodbye.
Goodbye.